Hello everyone, I am Nikhila from the Department of Artificial Intelligence and Data Science. In this presentation, I will explain the multi-layer perceptron neural network implemented in Python to solve the XOR problem. The XOR problem is a nonlinear classification problem, which means it cannot be solved using a simple linear model. Therefore, we use neural network with a hidden layer to learn this pattern. The Python code is implemented using NumPy for numerical computation and matplot library for plotting the training loss. First, the program defines the input and output of the XOR problem. The input matrix contains the four combinations 0, 0, 0, 1 and 1, 0. The expected output is XOR of 0, 0 is equal to 0, XOR of 0, 1 is equal to 1, XOR of 1, 0 is equal to 1, XOR of 1, 1 is equal to 0. Next, the neural network structure is defined. The neural network has 2 input neurons, 1 output neuron and 2 hidden neurons. The learning rate is set to 0.1, which control how fast the weights are updated during training. Next, the program initializes the weight matrices W1 and W2. W1 connects the input layer to the hidden layer. W2 connects the layer to the output layer. The neural network uses the sigmoid activation function, which converts values into a range between 0 and 1. The sigmoid function helps the neural network learn nonlinear pattern like XOR. The function forward underscore prop performs forward propagation. First, the program calculates Z1 is equal to W into X. Then the sigmoid function is applied to produce the hidden layer activation A1. Next, Z2 is equal to W2 into A1. Again, the sigmoid function is applied to get the final output A2. This output represents the predicted value of the neural network. The function back underscore propagation performs back propagation, which calculates the error and updates the weights. First, the error becomes the predicted output and the actual output is calculated. Then the gradients dw1 and dw2 are computed. These gradients show how much the weight should change to reduce the error. The weights are updated using the formula weight is equal to weight minus learning rate into gradient. The process is repeated for 10,000 iterations, allowing the network to learn the XOR pattern. During training, the program stores the loss values, which measure how well the neural network is learning. These values are plotted using matplot library, showing how the loss decreases over time. Finally, the predict function tests the trained network with different inputs and prints the predicted output. The result shows that neural network successfully learns the XOR problem. In conclusion, this program demonstrates how a multi-layer perceptron neural network can solve the XOR problem using forward propagation and backward propagation. It also shows how neural network learns patterns by adjusting weights during training. Thank you.